welcome to my YouTube channel. So today I'm talking about confidence interval. So confidence intervals are intervals that capture the true population mean with a certain level of confidence. Most often we'll use 95%, and if we're dealing with larger sample sizes, it will be the mean plus or minus 1.96 times the standard error. Okay, so I'm going to get into the real interpretation of confidence intervals real quick. Although, I don't know, I feel like it's a petty distinction, but it's a distinction a lot of people will really care about for some reason. Okay, so the interpretation of a confidence interval is that if you repeat the same sampling process many times independently, 95% of those confidence intervals that you create will capture the true population mean. If you're talking in the frequentist sense, it is incorrect to say that there's a 95% chance the population parameter is in your confidence interval. That is technically not true. If we're thinking about the frequentist sense, with all of the statistics you learn early on are frequentist, then the population, even though you don't know it, it's a fixed. The population mean, even though it's a fixed parameter, even though you don't know it, it exists. It's a real value that exists in the world, and it is not fairy. So it is incorrect to say that your confidence interval has a 95% chance of capturing it. It either caught it or it did not. There is no such thing as chance with that. It's a real value, and it's either in there or it's not. So therefore, you have to make a somewhat awkward statement that if you repeated the process many times independently, 95% of those theoretical confidence intervals would capture your true population parameter. Okay, now we got that out of the way. So, most of the time we do it for the mean. You can do confidence interval for other things, like a standard deviation. You can do a confidence interval for that, but you probably won't unless you're taking an upper level statistics class. You're most likely making a confidence interval for the mean. Okay, so what is a confidence interval? So it is comprised of the sample mean plus or minus a margin of error. The margin of error is the C-score times the standard error. So if you're... was it C-score or T-score? I'm second guessing myself on the C or T. C-score. Not, anyway. Oh, yes. Okay, so if you have a large enough sample size, above, let's say 30, although some people would say closer to 60, you can achieve 1.96. That is the value for a purely normal distribution. If you have less than 30, you have to use the corresponding t-score based on your degrees of freedom. So if you have a sample size of 10, you have n-1 degree of freedom, 9, and you gotta go look it up in your table to get the proper bound for a 95% confidence interval. And I'm not going to go through that per se, but that's what you'd have to do. Assuming you have a sample size more than 30, let's use 1.96. Okay, so the first thing you do, you get the sample mean. I made a video about that a few videos back. And honestly, if you need the video about the sample mean, you're not ready for confidence interval. You calculate the standard error. Another video about that a few videos back. You find the appropriate critical value. For a 95% confidence interval, it would be 1.96. I believe for a 90% it'd be 1.68, but I would look that up. Don't quote me on that. You multiply that critical value times your standard error, and then you add it and subtract that value called the margin of error from the sample mean, and that gives you your confidence interval. So let's go through an example. So we have 5 values, certainly short of the 30 I just quoted, but we're going to pretend it's normal. I don't care. So we get the sample mean, just like we always do, add all the numbers up and divide by the number of numbers you added up. And then you get the standard error, so you calculate the standard deviation and divide by the square root of n, and that will give you your standard error. And then you choose the confidence level, I mean, which is probably going to be 95%, unless you have to do something different, which is unlikely in the real world, but in a class, yeah, that's fair game, 90%, 99%. So if you have more confidence, it's going to be wider. But if you have a 99% confidence interval, it's going to be more than 1.96. It's going to be in the 2s or 3. I don't know offhand, but it's going to be wider to make you more confident that your value is in that range. Okay, so we get the margin of error, and then you add and subtract the margin of error from the mean. And then that is your confidence interval. And just remember, when you're doing foundational statistics, it's inappropriate to say there's a 95% chance that the confidence interval captured the population parameter. If people get real weird about it, it's really, if you repeated the process many times, 95% of those would capture the true parameter. If you're doing Bayesian statistics, you can make that statement, but in frequency statistics, which you're almost always doing first, you cannot make that statement without people getting mad. Okay, so what it affects confidence interval? Sample size. Larger sample sizes make more narrow confidence intervals. That's because larger sample sizes increase the denominator of your standard error calculation. And a larger denominator in your standard error calculation means a lower standard error means a smaller number being multiplied by your t-value or t-score, depending on your sample size, and then ultimately being added and subtracted from the mean. Confidence level. I already said that. Higher confidence level will make wider interval because you need to be more sure you captured that true parameter. More variable data will make your confidence interval wider because, once again, the standard error calculation, the numerator is standard deviation. So that directly affects the width of your confidence interval. Okay, so confidence intervals are for making inferences about population parameters and what they are. So it gives you a range of plausible values for your confidence interval. It doesn't always work. You're assuming normally distributed data or data that's not messed up enough to where the central limit theorem kicks in. So most of the time, I'd assume DOT will apply, but sometimes it doesn't. Like the Kautsky distribution, where you have a non-finite variance that will never kick in. In some distributions that require a larger sample size to kick in. And the assumption is 30 or more conservatively 60, but some might be more like 120, and That's really something you'd have to look up if you cared. Most people, especially if you're just starting out autistic, absolutely do not care. They'll just do it. And that may or may not be right. But, yeah, so, yeah, that's the confidence interval, and that's the end of the video. Thanks for watching.